Hello everyone. Today me and my fellow classmates will be presenting about integration by area. Next slide. What is integral area? The integral area is a double integral over the three coordinates giving the area within some region. If a plane curve is given by, then the area between the curve and the x-axis from is given by. Integration can be used to calculate areas. In simple cases, the area is given by a single definite integral, but sometimes the integral gives a negative answer which is minus the area. And in more complicated cases, the correct answer can be obtained only by splitting the area into several parts and adding or subtracting the appropriate integrals. Next slide. How do we calculate area by integral? Find the area between a curve, the x-axis, and the two given coordinates. Find the area between a curve and the x-axis, where the coordinates are given by the points where the curve crosses the x-axis. Find the area between the two curves.
Thank you, Mr. Hakam, for explaining what is an integral area. Now I'll be continuing and giving some examples. Example 1. Define integrals. So far, when integrating, there has always been a constant term left. For this reason, such integrals are known as indefinite integrals. So whenever there's a question which has always a constant term left, this question is called indefinite integrals. So how do we solve this question? Previous slide, please. So how do we solve this question with indefinite integrals? Now this question, we read it as this question means to the integral of x plus 3x squared with respect to x between x8 and x equals to 4. Next question. Solution. With indefinite integrals, we integrate a function between 2 points, and so we can find the precise value of the integral, and there is no need for any unknown constant terms. The constant terms cancel out. This means the integral of x plus 3x squared with respect to x between x equals 8 and x equals 4 are integrating. As you can see, it's the solutions there. Note that the constant terms disappears, and always with one definite integral, so you don't have to write them in. That's how we solve the first question. The second question is the area under a curve. This is the second example. The area under a curve between 2 points can be found by doing a definite integral between the 2 points. Example, what is the area between the curve y equals x squared times 4 and the x-axis? The shaded area is the area that we want. Next. Solution. To find the area under the curve y, fx between x equals a and x equals b, integrate y equals fx between the limits of a and b. Areas under the x-axis will come out negative, and areas above the x-axis will be positive. This means that you have to be careful when finding an area which is partly above and partly down below the x-axis. So whenever finding an area that doesn't have a very high difference between the area below and up, you must be really careful so you can know the answer. Example, what is the area between the curve y equals x squared times 4 and the area and the x-axis? We can exactly work out that the curve crosses the x-axis when x equals -2 and x equals 2. To find the area, therefore, we integrate the function between -2 and 2. And how we see we're integrating, note the area is negative because it is below the x-axis. Areas above the x-axis, on the other hand, give positive results. Thank you. Now Mr. Mustafa will continue.
So now I will be talking about the real-life application of integration by area. Differentiation and integration considered by all scientists throughout the ages as one of the best sciences that guided the mind of man over all times. The fields of the use of calculus are very wide. It enters into many fields and are not limited to specific people or to those who use it only, but to almost all human beings. Here are some examples of its benefits. The first example is what do we do if we are asked to calculate the amount of water required to fill a large swimming pool? just as the photo shows us. The answer is to determine the shape of the swimming pool first and find its size. Therefore, we find the size of the water that will fill it. If it is a cubic or parallel rectangle, finding its size is not difficult in any way because these geometric shapes are regular. Any student can find their size, but what if the size of the swimming pool is not a regular geometric shape? So it's irregular. It begins with a slight gradient and then the slope descends steeply. Then the sides of the pool become curved or semi-elliptical. Then it tends to rise slightly. It is easy to find the size of the water to fill this pool. The second example is finding the center of mass and weight and central axis of a car. And to determine the factors of security and safety on different roads and different speeds of the car. This is also done by calculus, of course.
Thank you everyone for listening. This PowerPoint was represented by my fellow classmates, Rashid, alblooshi, and Mustafa Ibrahim, and myself, hakam, amer. Thank you.